and welcome back to my another part where I work with FinRock project. Right now I want to introduce you this second part there. I'll show you what I changed from my previous part when I did this recording. So right now you can see the action of the render right now of current system running in version 2. And this is sinusoid data, simple data just to make some data that I could work on. And you can see here there is sell actions and buy actions and etc. And this is some kind of simulation that I'm creating for my further development. And right now, if you haven't watched my first tutorial, I totally recommend to do that before continuing on this one, because there I can open my GitHub. I can show you there I introduced my first iteration of this FinRock package, library, project, or whatever how you call, and this is the structure I have implemented. And this were missing live data, assets, and AI part where I haven't done this yet. Right now it's still haven't done this. I do this in random, but only because I want to finish this crucial backbone that we can continue working on. So this project is FinRock. You can find this on GitHub. And right now I implemented many changes that you can see in following image. As you might see, I added to the same system, I added reward function, data transformation function. And you might ask why we need this. Well, basically reward function is necessary when our agent is learning whether it did good action or bad action. So when it does some kind of good actions, we reward it for this kind of good stuff, and when it has some loss or etc., we punish it not to do this again. And same we want to introduce in this system. Next, I added this data transformer, and because if you were following my previous tutorial, you might saw that I created an object that I call state. And basically, when we want to use this in some kind of machine learning or etc., we can't use some objects. It's necessary to have a structured data as NumPy and etc. So these data are necessary to transform our collection of states, for example, history of states of 50 history steps and etc. to some NumPy array that we could use. Also, it's necessary to transform data, for example, to scale it between 0 and 1 for faster training of our models. Also, there wasn't an asset involved in our environment, so I added it so we can now set all of these independently. Next, they all communicate with trading environment that I call simulation for now. And next, I updated the environment in Pygame, and that you already can see working where it is right now, because before it was simple. We weren't able to see any actions going on live. So right now you can see this live, you can see maximum and minimal values in our data and etc. And all of these are for next tutorial, because it will be more difficult to implement, but I will do this. So I implemented these, but right now I'm showing you this only in this kind of simple image where I draw everything, and now I can walk through code to make you more familiar to understand what changed. And right now there is my same playing.py code script that I'm running, and you might see that I'm doing random actions, at least for now. You can also try to do action of 0, that is always hold, and this means it will not do anything. And here I simply parade the information that is account value and rewards, and you might see that in this data after this iteration, or one iteration of environment finished, one game or I don't know how we call it. And yeah, I'll right now gonna stop it because we don't need to run this in while I'm explaining you this stuff. But it would be way better if I'll show you this in Git graph that you'll be able to see changes. So as you might see, I added this scalar. That's what I showed you. That is a data transformer and reward. This is our reward function. And we are adding this into our training environment. And here is my initial balance. That's also new stuff that we set our balance at first, because, well, we need to know what is initial balance to and what our profits and etc. to improve it. Max episode steps is the same, and before we didn't have this window size. This means window size that, for example, we are collecting 50 time steps. So this means we are collecting 50 candles of history that we're gonna use for training our AI model, machine learning model, or etc. It's up to you what you're gonna choose, but I will focus in reinforcement learning in next part. And this is my reward function that I add. Next is simply the same Pygame that I render. And here is for display only to check what are our rewards and what our account value is at each end of my episode. And that's it. And you can see the results here. At first episode, we left with 886, and on second, we left with 350. And that's the main idea of this random stuff. And later I'll run this without rendering. You'll see that it works way faster, and you will be able to compare the random stuff later and with machine learning actions later, of course, in next tutorial. So that's it about this playing, but you can continue working from this part. And let's go to min-max scalar, for example. This is transformers. Where's my scalars? Yeah, that's scalars. And there's min-max scalars, and this is the object that's gonna transform the collection of states in something more useful as NumPy array. As you might see, it returns the NumPy array, and this is only a simple stuff for the beginning, but that might work when we start. But later we'll change this to something better, and we'll need to test this out if it is better. And you might see that there's observations and that I import from state. So let's move to my state. Let's see what's changed here. There was my state that was pretty basic, but right now I added balance, assets, and allocation percentage. So what's this? Well, this balance represents your cash balance. This represents your assets balance, and allocation percentage. This represents how many is allocated on an assets. For example, if we have 1000 in balance and we use 500, this means that this allocation will be 0.5. So this is necessary to calculate the reward function and to know whether we did and what action we did before, whether it was buy, sell, hold, or whatever. And next is a few helper stuff. So I use a properties for this so that we wouldn't be able to change this, but we would able to get these results as balance, assets, allocation percentage, and etc. And next I created these observations that I talked, and this is the collection of states that I told before, and we have this window size that in here I set it as 50. And what it simply does, when we add a new state to it, if it's longer than 50, for example, there comes 50 first, so this means that it's too long, so we drop one of them. And that's it, and then when we ask it to return these observations, it returns the list of them. That's simply the collections where we do this transformation. And if I go to my scalars where I was before, it receives this list of observations where we iterate them and we simply transform this stuff into NumPy array. That's it. And next, what I did here with data feeder. Yeah, with data feeder, I added a few more stuff here. So we usually, when we are using some kind of scalars, we are interested to know what is our minimums and maximums in our data set. Also, we would be interested to have some kind of standard deviation or mean and etc. But this is not for this tutorial. Later, if I'll create some kind of transformer that would use this, I will add this. But right now it's pretty simple. And you must see that when we try to get some item, it works exactly the same as before. And yeah, and I go to my trading environment, and here stuff changed the most. And if I have here observations, simple reward, etc., that's all the stuff I talked before. And right now, if there was only 2 argument stuff, data feeder and maximum episode stamps, here is right now way more as transformer, initial balance, window size, reward function, and etc. And we save these here. Also, we are interested to know what is our observation space, whether we want to use machine learning for this. So when I create this environment, it resets this environment and calculates what is our size that we return from this environment, what is the shape of data, and we want to know what is the action space. Well, this is kind of 0, 1, and 2 action space. And that's the improvement. And next, what we do is I slightly change this, how we get the observation. So we could add initial balance to our state when we are resetting, or when we are simply getting this observation with a balance value inside of it. So this one haven't changed, and then comes the take action. And yeah, before it wasn't implemented, I believe. Yeah, it wasn't. So when we are taking action, there is 3 possible actions right now, whether it is hold, sell, or buy. And usually we want to validate whether our action is valid or not. For example, if our action is buy, but our balance is 0, it's not available to do so. This means we change our action to hold. And the same happens to sell, when we don't have anything what to sell, our action changes to hold. So this way we are ensuring that there won't be any bad actions. And when these actions happen, we need to change our values on our state, however they change. And we are not changing the current state, but we are changing the next state that we're going to receive. And these states are saved in observations. We'll come to this. And yeah, we change it accordingly. If you want, you can further analyze this. And I'm not explaining step by step here. And this also a little change, this step function, that we are receiving this observation, for example, on the step from our data feeder, and we are adding this or appending to observations object that has same function as the list. Is simply append, and we add this observation, and this observation is simply a state, and this holds all these states. And next we have this take action that we already covered, and for now I hard coded this order size that later will be changed by the machine learning model. But for now, I made it stable as 1. Whether we buy one or sell one, it's up to us. And next, I added this reward function to use. And you might ask why I added this as a function, not like a hard coder in this object code or etc. Well, because I tried to make this environment project into object oriented and make it as objective as possible, because later if I would like to test different word functions, it will be way easier for me to simply change this function to my custom function, and I won't need to change all the code in my environment, and it will work. And next is my transformer. As you might see, I have here transformed observations, and this simply it calls a transformation on each step. And these transformations are simply in my scalars functions. And that's it. I returned the same stuff, almost the same, but they are different. And what happens here, I reset it, also slightly changed. I need to reset observations object, and I check whether it's not full. And usually I need to make it full before continue working, because, for example, if our window size is 50, I iterate through my data feeder until I receive the last, for example, state. If this would be my live data, I'm interested to collect some history, I don't know, a few hundred time steps until I achieve current time step, and then I would know that it's full, and then I'm ready to continue this environment to do some predictions or etc. So I'm trying to create this very similar when we are working with offline data that we use from CSV or etc. It's up to you, and simply we imitate the same process that we collect the data, when we achieve this, we then do step every iteration as we would do in live data. And then I simply update the info dictionary with my list of states, and I transform data, and I return this transformed data. And that's it about that. And if I would go back to my playing, I can run this in debug, and you might see what are the results of this. So I create this environment, I run this, and we'll stop here at the environment reset step. And you might see, where's my render? Okay, it's here, but it's not showing anything yet. So I move it here, and you might see that there is a state, and it's already transformed state, and I can print this out, state shape, and it's my 50 by 5, and let's look at it closer. And this is my transformed state. There is open, high, low, and close values that were transformed with min-max scalar and pushed into, transformed into 0 and 1 values. And that's it. And here is my allocation percentage. And this changes later. So let's continue looking at this. And here is my info, as you might see. And this, as before, this returns a state. There is a lot of state objects that are used for rendering. As you might see, I push this through the render. So this works pretty fine, and let's move on. So I render the environment. Let's look at it. You might see I rendered 50 states right now. That's my initial states that I'm render and I look at without any actions. And then let's look at next. So let's make an action. Action will be 1. So this is cell. This means I won't do anything. And I do another step. And this gives me a state with the same shape. 50 by 5, and this means that we will be able to use this in our machine learning model. Nothing changed between, but right now it's a little different. We can see that here nothing changed, balance is the same, no allocation. Okay, let's move on to another action. I'm interested to see another better action. Action, what is my action? 0, this means nothing. We need 2. Let's move on. Well, here it is 2. This means that we're gonna do a buy here. And let's move. And right now, let's print our state. And this is 1. This means that we here bought everything for all the balance we have. And if I look at my info at the state, what we have here, we have allocation percentage as 1, account value as 1100. This means that our price went up. Let's look at it. I haven't rendered it yet, so I need to go there at this step. It should be rendered right now. Let's look. So this means that we did a buy here at the red close, and here it went up. So now we are receiving the price of the close. This means that we should have received a huge profit. That's great. And let's move again to another step. Action 2, this means nothing changes for now. Action 2 again, action 2 again, action 0, it will do nothing again. How it changed? You can see nothing happens here. Oh, so we did sell here. So let's look at my chart. Why it's not showing? Yeah, so we did sell here at the close. So this means that our info should have a state where we have account value of 1030. That's great. And balance, yeah, something like that. Oh, it means we sold it on the close. We sold it here, right? So it has a little lower than we expect. But yeah, that's the idea, is we always do an action on the close. And yeah, we need to figure it out, but that's how it works. And I can run this again, and we'll see how it works. And you might see it jumps around, up and down, and etc. And nothing happens here. But the idea here that this render is improved right now, I can resize it however I want. It will adapt to my needs. Cool, isn't it? And you can change this render speed if you're interested by simply frame rate and etc. And that's it. And let's close this, and it works way faster without rendering. So let's close, and you might see that right now it works on one game. It finished with 800, second 1,700, 11,000. That can be true, but it is. Well, all of this happens randomly on sinusoid data, and you might see that we would like it to always be in huge profit, but right now it's sometimes wins, sometimes loses, and etc. And the goal is to train a reinforcement learning that could work or predict this sinusoid data. And we would be able then replace this sinusoid data with, for example, random data. And with random data, it wouldn't be able to learn anything because random data is unpredictable. And then we would be able to replace this with our finance data. And then we will see whether it's possible or not to learn something from price data. And that's it. That's the goal of few next tutorials that I of course gonna record and show with you. And if you finished up to this point, don't hesitate to smash the like button. It means a lot for me while creating this content and investigating the problems and giving it for you in open source, and to sharing my knowledge and sharing my time with you. So if you would press the like button or subscribe or comment, I would be really happy to know that. And if you have any questions, suggestions, whatever, you can always leave comment, open issue on GitHub, or ask any questions or suggestions you want me to do. So that's it about this tutorial. If you want to download this code, I already created this description how you can load this, and simply you will be able to open this code. I will add a tag of 2 to this branch, and you can also download the zip of this code, and that's it. Yeah, and of course, don't hesitate to smash the like button. And I'm not creating a separate text tutorial where I will post a copy of my code. I will simply continue working on this. So if you want to get some code from, for example, this tutorial, you need to open my GitHub history and go to specific branch as I showed here and clone it and use it and work on it or test it however you want. So that's it about this tutorial. I hope that you loved it, you liked it, and etc. And we'll see you next time. Thank you for watching, and bye.